2008 Beijing Olympics. I'll be your announcer. I'll now show you where the competitions will take place. This is the water cube, where the swimming competition will take place. Over here is the area where the weightlifting competition will take place. And over there behind the gymnasium is where the running competition will take place. Now we'll take you to the water cube, where the 50 free swimming competition is taking place. Welcome to the water cube. We will soon be starting the 50 free. I will now introduce you to the competitors. We have Choi from the United States. And we have a South Korean competitor. This should be an exciting matchup. We will now take you to Jeff Miller, who is commentating on the match.
This is a 50-yard freestyle, 4 lengths of the pool. Gentlemen, take your mark, go. Here we are at the 50 freestyle between Choi and his South Korean competitor. Choi out to a great start, way in front of his competitor, with a very slow turn, and his competitor with a great turn. Here we are at the last turn of the race. The South Korean takes the lead. This is gonna be down to the wire. It's gonna be close, and he wins! The South Korean takes home the gold. And look at that excessive celebration. Josh is not happy at all. He is very disappointed.
Welcome to the weightlifting competition. We have David Kwon representing the USA, who will attempt to lift 300 pounds. If he succeeds, he'll win the gold medal.
Attempting to lift 300 pounds, David Kwon.
Ouch! That was heavy.
He cannot get it and must settle for silver.
Welcome to the 100-meter dash. This is Jeff Miller from the United States. And this is his South Korean opponent. This should be an exciting matchup.
This is a very intriguing matchup between Miller and his South Korean competitor. This is a 100-meter dash. Start out even. Jeff and David looking good. Oh, and Miller gets a cramp. Oh, this cannot be good. The South Korean competitor wins. And look at that. He is excessive celebration right there. Oh man. Jeff is not looking good right now.
You know, that was one tough Beijing Olympics. I only got second place in my best event. And I don't know why I cramped up on those last 2 feet of the race.
Yeah, I cramped up on the last lap too. Can't believe that South Korean beat me. How do I get faster?
Yeah, I need to learn how to contract my muscles better.
You know, I know a guy who knows a guy.
Really?
Dr. Din. He's
Dr.
trained pro athletes.
Like who?
LaDainian Tomlinson.
LT?
Yeah.
He's my hero.
Yeah. You know, I'm gonna go talk to him right now. And I'm gonna see what I can learn from him.
You better pay attention.
You better get some good info.
I will.
If you want to get better.
Bye.
Wish me luck.
Good luck.
Dr. Din?
Come in.
Okay, so I got a cramp in my sprinting race during the Olympics. My swimming teammate got a cramp in the last lap, and he also got second place as well as I did. And my weightlifting teammate did not lift what he wanted to, and he also got second place. Do you think you can help us out?
Let me tell you something about muscles. A muscle fiber is a bundle of smaller myofibrils. The myofibrils are composed of 2 kinds of myofilaments, thin filaments and thick filaments. Thin filaments consist of 2 strands of actin and 1 strand of regulatory protein, coiled around one another. Thick filaments are staggered arrays of myosin molecules. And these are thick filaments and these are thin filaments.
Wow. Okay, so this will help out David, or my weightlifting teammate?
Yes. According to the sliding filament model of muscle contraction, neither the thin filaments nor the thick filaments change in length when the sarcomere shortens. Rather, the filaments slide past each other. The sliding of the filaments is based on interaction between the actin and myosin molecules that make up the thick and thin filaments. Each myosin molecule consists of a long tail region and a globular head region extending to the side. The tail adheres to the tails of other myosin molecules. The head is the center of bioenergetic reactions that power muscle contractions. It can bind ATP and hydrolyze it into ADP and inorganic phosphate. And these are the interactions between myosin and actin.
Okay.
And for your swimming friend, because most animals are reasonably buoyant in water, overcoming gravity is less of a problem for swimming animals than for species that move on land or through the air. On the other hand, water is a much denser and more viscous medium than air, and thus friction is a major problem for aquatic animals. A sleek, torpedo-like shape is a common adaptation of fast swimmers, like your swimming buddy.
I'll make sure I tell him that.
And for your cramps, the cause of your cramps is lactic acid fermentation. During lactic acid fermentation, pyruvate is reduced directly by NADH to form lactate as an end product, with no release of CO2. Human muscle cells make ATP by lactic acid fermentation when oxygen is not available. This occurs during the early stages of strenuous exercise, when sugar catabolism for ATP production outpaces the muscle's supply of oxygen from the blood. Under these conditions, the cells switch from aerobic respiration to fermentation. The lactate that accumulates may cause muscle fatigue and pain, but the lactate is gradually carried away by the blood to the liver. Lactate is converted back to pyruvate by liver cells, and this is lactic acid fermentation.
Okay, and I also heard that eating a banana before exercising will prevent cramps. Is that true?
That is true. Bananas have essential vitamins in them. So far, 13 vitamins essential to humans have been identified.